Good morning students. In this video, I will be discussing on the various line coding techniques we are using in data communication. So here you can see the various techniques, that is line coding techniques. These are the various categories. We have unipolar non-return zero technique, and then we have polar techniques. In that we have non-return zero as well as return zero, and also biphase. In biphase we have Manchester and differential Manchester encoding techniques. When it comes to bipolar, again we have AMI and pseudo ternary, that is alternate mark inversion and pseudo ternary. Then we have multi-level, we have 2B/1Q, 8B/60 and 4D PAM5, and in multi-transition we have MLT3. However, in this video I will be discussing only these three techniques, that is unipolar, polar and bipolar, as these are the three important techniques today we are using. So these two, multi-level and multi-transition, I will be discussing in next video, okay, upcoming video. So let's start. So first we will see what is unipolar non-return zero. So these line codings are mainly used to represent the binary data into its signal form. So here you can see in unipolar line coding scheme, always the positive voltage defines a bit 1. So whenever there is a bit 1, you should take the positive voltage, and whenever there is a bit 0, you should take the 0 voltage. So here there is some binary data like 1 0 1 1 0. Okay, here you can see, as I told you here, if there is a bit 1, you should take positive voltage, and bit 0 0 voltage. Here you can see, since 1 we have, I am taking some positive voltage here, and when there is a 0, then I should go to the down and then go for 0 voltage. And next we have 1, so positive voltage. Again 1 is there, so I am continuing in the same positive voltage. Then we have 0, then come down and then go for 0 voltage. So this is nothing but just a slot, means timeline, where you can change the phase. Okay. Hope you understood that. It's very simple. Whenever there is a bit 1, go for high voltage, that is positive voltage. Whenever there is a 0, go to a 0 voltage. This is what we call as unipolar non-return zero technique. So coming to polar non-return zero, we have two types in that. One is known as NRZL, that is non-return zero level, and one more we have known as NRZI, that is non-return zero invert. So first we will see what is non-return zero L. So in NRZL, what happens? Whenever there is a 1, binary 1, so you should go for high voltage, and binary 0, you should go for low voltage, not 0 voltage, low voltage, means negative voltage. Here you can see, whenever there is a 0, there will be a positive voltage here. Okay, whenever there is a 1, you should go for negative voltage, negative cycle. Similarly, when there is a 0, positive voltage, and again there is a 0, continue the same positive voltage. When the 1 comes, negative voltage, means negative cycle. Again 1, continue with the name negative cycle. Again 1, continue with the same negative cycle. 0 is there, go for positive cycle. So hope you understood. So we have NRZ means NRZ invert. What happens here? It purely depends upon the next bit. Means first bit, let it be anything. You can take either positive cycle or negative cycle. If the next bit is 1, then you should go for transiting. Means you should change the position. If the next bit is 0, then there is no transition. So what I mean to say, here you can see, if the next bit is 0, there is no inversion or there is no transition. If the next bit is 1, you should invert your cycle. Means what I mean to say, here you can see, the first bit may be anything, the cycle may be anything. Here they have taken the positive cycle, or you can go for negative cycle, it is left to you. But if the next bit is 1, so if the next bit is 1, what I should do? I should inverse my cycle. So here it is positive, then I should go to negative, come down to this timeline, and negative cycle I have taken. So my next bit is now 0 again. So here you can see 0, 1, 0, 0, 1, 1, 1, 0. So my next bit is 0 here. 0 means what? no inversion. So I am continuing the same cycle, negative cycle. Again, next bit is 0. Continue with the same negative cycle. Next bit is 1. Then you should change your position inwards. So time when you go up, go for positive cycle. Again, next bit is 1. Then change the position. Come to the negative cycle and then draw. Again, next bit is 1. Invert. Go to the positive cycle and draw the cycle. And next bit is 0. So no inversion. Continue with the same cycle. So in this way, the polar non-return 0 inverted is depends upon the next bit what is there. If the next bit is 1, you just invert the cycle. If the next bit is 0, don't invert, continue with the same cycle. But the first bit may be any cycle. It may be a positive cycle or it may be a negative cycle. Okay, hope so you understood. Next, polar return 0. In polar return 0, what happens? There will be 3 voltages, that is positive voltage, negative voltage as well as 0 voltage. And in this scheme, signal goes to 0 in the middle of each bit. So here you can see, if there is a 0, 50% of negative cycle will be there here like this, and 50% it will go 0 voltage. If it is a 0, 50% negative cycle and 50% 0 voltage. And if it is 1, 50% positive cycle and 50% 0 voltage. That's what the name. If the in this scheme, signal goes to 0 in the middle of each bit. That's what in the middle. It may be a positive cycle or it may be a negative. It may be a 0 bit or it may be a 1 bit. 50% there will be a 0 voltage. Here you can see. But the remaining 50%, if it is 0, it is negative cycle. If it is 1, it is positive cycle. Hope you understood. Now again you see 0. So 50% negative cycle and 50% 0 voltage. And again 0, 50% negative cycle, 50% 0 voltage. And 1, 50% positive cycle and 50% 0 voltage. So whenever there is a 0, then 50% negative cycle and 50% positive voltage, 0 voltage. Whenever there is a 1, 50% positive voltage and 50% 0 voltage. This is what we call as polar return 0. Okay. Here we have 2 types. One is known as polar Manchester. The other one is differential Manchester. So in polar Manchester, what happens? Whenever there is a bit 0, okay, 50% positive cycle you should take and the remaining 50% you should take negative cycle. There is no 0 voltage here. You can see here, if this is your time vertical timeline, time axis, so 50% positive cycle and 50% negative cycle if it is 0, and if it is 1, then 50% negative cycle and 50% positive cycle. Hope you understood. Here you can see now, when there is a 0, 50% positive cycle and 50% negative cycle. Then is 1, then 50% negative cycle, 50% positive cycle. 0, 50% negative cycle and 50% positive cycle, 50% negative cycle. Again we have 0, then go up because you should take 50% positive cycle and 50% negative cycle. Next we have 1, 50% negative cycle, 50% positive cycle. Again we have 1, so come down in the timeline, 50% negative cycle and 50% positive cycle. Hope you understood. This is very important. And when it comes to differential Manchester, it is almost like your N or Z inverted. So the first bit may be anything. Either you can take from negative cycle to positive cycle 50%, or you can take like 50% positive cycle to 50% negative cycle. The first bit may be anything, but it purely depends upon the next bit. So if the next bit is 1, then you should not do any inversion. If the next bit is 0, then you should do the inversion. Here you can see now it is almost like this one, but here there is a single voltage, either positive or negative, but here there are 2 cycle bits, means 50% positive and 50% negative. So whenever the 1 comes, the next bit is 1 here, 0, 1, 0, 0, 1, 1. So the first bit I have taken negative to positive. Let it be anything. Either you can take from positive to negative. So we are not bothered it. So it purely depends upon the next bit. If the next bit is 1, then no inversion. So I am just continuing the cycle from the same positive cycle, 50% positive, 50% negative. Next bit is 0. If the next bit is 0, invert. So I should go back up and then 50% positive, 50% negative. The next bit is 0. again invert, go up, and then 50% positive and 50% negative. Next bit is 1, so no inversion. So continue with the same cycle, 50% negative and 50% positive. And next bit is 1, again no inversion, continue with the same cycle, 50% positive and 50% negative. So whenever there is the next bit is 1, then don't do any inversion, continue with the same cycle. Whenever there is a 0, then you change the position and then continue. So this is what we call as differential man system. Hope you understood. And lastly we have bipolar, that is we have AMI, that is alternate mark inversion, and pseudo ternary. So in alternate mark inversion what happens? Whenever there is a 0, then there will be a 0 voltage, and whenever there is a 1, means 1 or alternative ones, then you should do alternate positive and negative voltages. Okay, how you will see here? See, in alternate mark inversion what happens? Whenever there is a 0, there is a 0 voltage. Okay, whenever there is a 1, it is alternate high and low. So first time it will be positive cycle. Okay, next if it is 0, no doubt it is 0 only, 0 0, and whenever you get 1 again, then first time it is positive, now it becomes negative cycle. Then if it is 0 0, if once again if you get 1 here, then it will be positive. Okay, again if you get 1, then it will be negative, come down and then go for negative cycle. So whenever the 1 comes, okay, for it will be alternating high and low. Here it is high, here it is low, again here it is high, and next it will be low. Like that, consecutive high and low will be there. Whenever there is a 0, it is 0 voltage. Okay, next we have what is one, the last one is pseudo ternary. It is the reverse of AMI. What happens here? Whenever there is a 0 bits are coming, like 0 1 0 0 1 0, so whenever there is 0 bits are coming, it will be alternative high and low. Whenever the 1 comes, it will be 0 voltage. For example, 0 is there, no, it will be high voltage first, then 1 comes 0 voltage, then 0 come, no, negative voltage, means low voltage, again 0 came high voltage, then 1 come 0 voltage, again 0 came, here it is positive, so now I will go to negative. So what happening here, it is the reverse of AMI. Whenever 1 comes, it is 0 voltage. Okay, whenever 0 comes now, it will be high and low. Okay, hope you understood. So thanks for watching, hope you enjoyed the video. Subscribe for subscribe the YouTube channel for more videos. Bye.